right here, there's only so many values that exist in those parentheses. There's 0, 1, 1/2, square root 3 over 2, and square root 2 over 2. And then obviously the negative and positive of those values. So you know, okay, it's going to be one of those values. We know that a decimal isn't equal to 1 or 0. We know that 0.866 isn't equal to 1/2. So we know that cosine pi over 6 has to be either root 2 over 2 or root 3 over 2. Does that make sense? Like there's only so many options that your cosine values can get you. So you're like, oh man, I can't remember if cosine pi over 6 is equal to root 3 over 2 or root 2 over 2, like what's it is. And you can just literally type in your calculator, root 3 divided by 2. Is that equal to 0.866? It is. And then if you had done root 2 divided by 2 first, you would see that's equal to 0.707. This is kind of what I'm saying makes sense. You can double check that decimal value by just inputting the value you think it is in your calculator. Yeah, and you can do the same thing with using the arc cosines. Do you have like a unit circle pulled up so I can put back? Okay, I'm gonna go back to my writing. Okay. It's the same thing for like arc cosines, right? So if we have beta is equal to the arc cosine of root 3 over 2, right? You're like, oh man, what it's either going to be some values of pi, right? So if you type in arc cosine or inverse cosine, it's like cosine with the -1 with root 3 divided by 2, you're going to get 0.5235. And you can just try different values dividing pi. Like pi divided by 6, that's equal to 0.52359. Or you could do pi divided by 3 and see what that's equal to until you kind of get a value that's using these pi values on the unit circle. I mean, it's not the best way to do it, but if you're like have anxiety on the test and you like forget or you just can't remember for whatever reason, it's a really great way to just to double check yourself.